We're going to use the midpoint method to estimate the y value for a given x value on a function. So take a look at the question. So what we're given is we're given the differential equation and the point on the line, and we're asked to, now note it doesn't actually ask us to use the midpoint method, it just gives us the formula, which might be good or it might not, but either way we're using the midpoint method, and this tells us what we want to find. What's the y value when x is 1.5? Here's our step length. So immediately we can start to fill in the table that I've already drawn underneath. So first our point is given to us, so our point 0. We're going to go up in 0.1s, that's our step length, until we get to 1.5. So 5 steps looks like. Okay, so first of all we we need to calculate the gradient at our initial point. So we calculate that using our differential equation. So that's 1 squared take away 2 squared, all divided by 1. So that's going to be -3. Now for the midpoint method, we want to go to find this y value, we want to go back 2 spaces or two rows to find our previous y value, but since we can only go back 1, we use Euler's step-by-step method just to find this one. So we're going to do, so here we're going to use the previous y value plus the step length times the gradient. So that's going to give us 1.7. Now to find the gradient at this point, we can use our differential equation, sub in our values, and that comes out as -1.527. Right, now we can use this midpoint method properly, because to find out this y value, we want to go back to 2 positions to find our y value there, but then we're going to find 2 step lengths using that gradient. So we're going to work out 2 plus 2 steps times the gradient of the previous step. So that gives us a y value of 1.695. Okay, so for at the end of step 2, start step 3, we can find the gradient at this point. So again, sub our values into our differential equation, and we get -1.1929. Right, now we're ready to find our y value here in step 3. So again, we're going to go back, not to the previous one but the one before, our y value there, and we're going to take 2 steps at that gradient. So it's going to be 1.7 plus 2 steps at that gradient. So that's going to give us a new y value of 1.461. Now we found the x and the y value for this third new point, then we can find out our gradient at this point, x squared minus y squared all over x, and that is going to be -0.34. That's 29. Great. Now we can take the the double step and go from 2 y values back and take 2 steps at that gradient. So 0.695, 2 steps at the subsequent gradient. And our value here is 1.626. One more double step to take, but before we do, we need to know the gradient at this, what will be the middle point when we're stepping up to our 5th point. So x squared minus y squared all over x gives us the value of minus 0.488. Let's add the 4th decimal place for good measure. Okay, so now we can find, for this value here we need to go back the 2 spaces for our y value and then take 2 steps at that gradient. So it's 1.461 plus 2 steps at that gradient. And our value is 1.3637. So final answer